The last calculator operation we're going to look at this time is finding the point of intersection of two functions while on the graph screen. Because if we can find the point of intersection of two functions, that's where the two functions are equal to each other, as we'll see when we actually do the homework problems in regards to this graphing calculator assignment. So finding the point of intersection of two functions while on the graph screen. Let's get two functions for starters. So y equals, I've already got my x squared minus 3. And I'm going to put in a second function, just the function y equals negative 1. All right, so let me put in those two values right there. And let's take a look at the graph. So there's the parabola of y equals x squared minus 3. And then here's the function y equals negative 1. And let's say I'm interested when x squared minus 3 is equal to negative 1. I'm interested in that point of intersection right there. Well, there's a command for that as well. And once again, it's located on the calculate menu. So we're going to hit second, trace, and option number 5 finds the spot, the x value and the y value where two functions are going to intersect. So, and when we hit enter on that, the graphing calculator asks, hey, what are the two functions that you're interested in? Well, this part's kind of easy because we're only graphing two functions. So we just have to hit enter twice. So I'm going to hit enter on the blue curve for the first curve. And notice how the butterfly automatically shifts to the red curve for the second one. So I'll hit enter again. Now, it seems kind of stupid that why would it ask for the two curves if there's only two curves? Well, in fact, if we go back to y equals, we see that we can add in up to 10 curves at the same time. And if we have 3, 4, 5, 10 curves on the screen, the calculator needs to know which two to focus on. We only have two curves on the screen, so that makes it rather easy. Oops, I've lost my place, so I got to go back and do that again. So second, trace, option 5, enter on the first curve, enter on the second curve, and now the guess. Now here's where we just got to be careful. If we guess over here on the right, it's going to find this point of intersection. If we guess over here on the left, it's going to find that point of intersection. Now we're interested in this one right here. It looks like it happens between 1 and 2. So I'll make the educated guess of 1.5. I'm going to type in 1.5. When I do so, I see that in fact it's 1.414, which some of you might recognize as the square root of 2, but that's the actual value of x where the two functions intersect. All right, so in other words, if x is equal to the square root of 2, then the functions will both be at y equals negative 1. Let's think about that for a second. If we go back, we know that y2 is always equal to negative 1. If x is equal to radical 2, well, radical 2 squared is just 2, and 2 minus 3, sure enough, is negative 1. So the math checks out here as well. But again, the key point to getting two functions to intersect, or finding where they intersect, second trace, and then option number 5.